Okay, we're going to do pressure, but this time we're going to use tank leveling with pressure. And we could level a tank, we could level a canal, a lake, we could monitor a level with pressure. So this is a lead site, and lead is right. It's about the green points, and setting a good environmental example with your site. So it's energy efficient, it's water efficient, and the like. So this tank collects rainwater and it connects air conditioning condensation, and it's to be used for irrigation use. This tank feeds an irrigation pump, but it's difficult to know when the water level's low, right? There's no sight glass on this, and I don't want to have to go out there and inspect it. Okay, so here's the goals for this one is remotely. I don't want to have to walk up to it. I want to know when this tank is 25%, 50%, 75%, and 100% full. I want to know that just by logging in and looking at my phone or looking at a computer remotely. And I want to stop using that tank water source and that pump when it gets down to 25% full. So when it drops down to a certain level, I want to discontinue this water source. I don't want to burn up the pump. And I don't want to suck up the sludge at the bottom of the tank either. Here's what we're going to do to make this happen. We're going to use the connection, a 1/4 inch connection, and a pressure bicoder. That's it. That's all we're doing. Okay. So let's think about how we're going to pull that together. So we're going to install and assign that pressure bicoder, right? That's important. We're going to note what that pressure reading is for a full tank. So whatever that pressure reading is, when that tank is full, that's 100%. And then we can monitor that in quick view. And then at water sources, we're going to set an empty condition. But before we set an empty condition based on soil moisture sensor, now we would do an empty condition based on pressure input. Okay. And here's what makes this work, right? So especially for people that are a little bit newer, is a 20-foot tall tank is about 1/2 pound of pressure. It's 0.433 PSI per foot of elevation. So that means that a full tank reads 8.66 PSI or damn close to it. Does it really matter what that number is when it's full? No, it doesn't. It doesn't matter if it's 8.67 or 8.23. It's going to be roughly 8.5 pounds of pressure when it's full, assuming the pressure transducer is at the bottom of the tank. Okay. But every time it's full, you will get that same number back. Half full, that's about 4.3 PSI. And when it's empty or almost empty, it's got a foot of water in there. We got 0.433 PSI. That knowledge is how we make this work. Okay. So let's take a look at programming on this one. So we said, what were my steps I wanted to do? So we wanted to assign assign the pressure bicoder. So we do that, make sure under devices, we'd have the pressure sensor assigned. Okay. And then what we can do is in quick view, we can look at my pressure sensors and I can see what my pressure is right here. So this is my dashboard for just seeing what it is at a glance. My pressure transducer is actually right here. And so it's reading 0 PSI. So yeah, that's not doing anything right now. Or it means the tank is empty, bone dry. Okay. When it's reading 8.66 PSI, I can tell it's 100% full. When it's 4.15 or 4 point whatever, I can tell that it's halfway. I can tell that at quick view. So that's monitoring it. But if I wanted to set an empty condition, we could go to flow setup, go to water sources. And under water sources, we can do edit, add an empty condition. In this case, we're going to do it based off of pressure. Got to pick the right pressure transducer. And when the pressure is below 0.433 PSI, wait 60 minutes and enable it. So in this case, when there's a foot of water left, it takes this water source offline and it will not burn up the pump. Okay, so excellent question. So Dave asked a question, would the sensor be installed in the bottom of the tank facing up? It doesn't matter. So here, let me switch my camera. So here's the biCoder, right? This is just allows us to connect into the 2-wire system. This and pressure transducers have been around for a long time. There's nothing particularly magic about it. But what was magic about this was making this reads 4 to 20 milliamps. And how do we turn that into, that's analog. How do we turn that into a digital signal? That's what this is all about. And honestly, 4 to 20 milliamp is used in a lot of different devices. And I'm nerding out trying to figure out what else you can run with this biCoder that reads 4 to 20 milliamps. So would you mount it this way? Probably not, because then it would probably collect debris in here. Honestly, I would just thread it into a T at the bottom of the tank, thread it in sideways in there. That would be the easiest way to do it. So an outlet fitting, that'd be super simple. Now, if you change this to a lake transducer, a 0 to 5 PSI, those are intended to be suspended, right? So those are intended to just hang like this. And the only thing that's really different on that is there's just a little protective cap on that. It took, when I ordered one, when I ordered one, the only thing I realized, it's the same thing. It just comes on a different cable, has a vent tube, and has a plastic cover to keep crap from getting in. It's identical. It's got the same thread. So if you were using this device, I would recommend threading it into a fitting that's accessible. I would probably not set it inside the tank, or you could drop one in and just hang it suspended. I think ultimately the difference between this and a lake level transducer is how are you going to mount it? Because if you didn't have the ability to thread into a fitting, you might have to hang it and drop it in.